yesterday we talked about the basic classes of IPv4. We were able to see the network IDs as well as host IDs. What could be the range which determines the network part or network portion of the IP addresses. Which one relates to the host IDs. Then again, we were able to see diagrams where many networks are there, how it is operated, how the IP addresses were assigned for network and the host. That was yesterday we discussed, and let's continue with some aspects of IPv4. Services, IP, basically this TCP IP protocol helps for network communication. Especially it supports one-to-one, that is we call unicast. One to all, broadcast, one to several, call it as multicast. So these services provide, say, I am here in the second one, because I am here and broadcasting to all, many people there. So this is the way you give this is the service rendered by the business. Very basic thing if you want to understand. Without IP, devices cannot make any sort of communication. Then IP multicast requires some protocols like IGMP, multicast routing. Then if you want to know all these routing protocols in detail, you have to for yourself, or else you may have to do some other networking classes, CCNA or something. Here, within our syllabus, we are not supposed to go that much deeper how protocols or routing protocols are configured, what all is all about. But anyway, those who are interested in the field of networking later part of your life, focus on those areas and extent. So basically, the class separates network from host bits. We were able to see yesterday by looking at the class and the default mask. We were able to see which could be the network IDs of any given IP address. For example, in 192.168.1.3, so we know that this range default mask basically 255.255.255.0. That is the default mask. Then we know that straight away the class should be C. And if you look at the network IDs of this particular range of IP addresses, the network ID will be 192.168.1.0, and you also can remember, we learned that the 0 is normally assigned for network address. Normally it refers to network address. Then if you look at the second one, 1.12.100.31, this basically from the class A, then you know the range 0 to 127 type. You can remember what we yesterday discussed. Then default mask is 255.0.0.0. Then again, then you can decide upon what should be the network ID of this particular network. Then if you take an example from class B IP address, so you can remember the range of class B IP address and the default mask. We know that the first two octet belongs to the network portion of IP address space. So if it is class B, so with the given IP address 172.30.7.5, this would give us, this should be the network address 172.30.0.0. So we know that 0 refers to the network address. So with this background, I hope that even you have already got the written note with you since the beginning of our module. So what I have done to test your knowledge, I have I have planned an exercise, in class exercise. So where you may have to fill the gaps. There are 3 IP addresses given. You may have to do the exercise in class by spending a maximum of 10 minutes. Maximum of 10 minutes. So what I would ask you to just log into the course page, that is our VLE course page. There you can see the assignment is given here. Assignment is given. I think the first assignment already there. You have to get that assignment also. So can you all log into the VLE and do the exercise IPv4 exercise 1, 3 in the information. So once you have done the information, you can upload the answers to the VLE. So is your work clear? Do you all understand what
yes,
I have said?
Sir, we should do right now, right?
Yes, yes. This is in class exercise. This is in class exercise. So you know, this is we have been talking about IP version 4. This is in class exercise. At the real lifetime learning that we are doing here. So dedicate yourself. Don't take this as granted. Be serious in your life and learn. And you will even remember later on when you go to the network environment, you feel that you have not got enough knowledge. That is not because of the system of the university, it is because of you. Right? Remember always, universities are there just to help you. You are the one who involved in a lot of learning. You are the undergraduate students, you have to do a lot of self-learning. So once you are done, please text me via chat box. Okay, let's move on. Next is next one is it is a protocol, ARP, Address Resolution Protocol. Address Resolution Protocol. This one we use for getting the information about IP addresses and the MAC address. So you know the meaning of the word MAC address. I have already discussed. MAC address will look like this. So, for example, if you go to the command prompt, you type R, so you will get some information. The ARP Address Resolution Protocol. So when after opening this command prompt, if you just type ARP, you will get the information. If you can type even ARPA, E like something, you can get. So see this ARP. Now you get the address of this, and you get the physical address of this. That is, this will show you the neighboring devices basically. They are in the network. That is what we call it the address resolution protocol. See, before an IP packet can be forwarded to another host, the MAC address usually 6 bytes written hexadecimal number. This MAC address domain must be known. So the R command this determines the MAC address that corresponds to the IP address. So the router will choose the right path for the network packets based on the IP frame that will do the next. So I will give you some hands-on exercises even for some command networking command tutorials I will do. I pray that you all can return to the university only very fast. So then only we can do many things. Right. So that is protocol, address resolution protocol. That is ARP, address resolution. If you click ARP A, you can see here the corresponding IP address, internet IP addresses, corresponding physical address. You know the meaning of physical address. Basically, the physical address and the hardware address. So the ARP command shows us the IP address as well as corresponding physical address. So I would always recommend you must become familiar with this command prompt if you would like to work with networking areas. Most probably you must be familiar with this command prompt. Nowadays you have a web interface also to configure the switches and router. But as a network professional, you must be familiar with the command prompt. So that is what I am also coaching you, giving you a training this time. That is R. Then next one is basically, as I said, it is a network layer protocol. Basically, network layer protocol used to convert an IP address into the physical address. Then you have another one is reverse RARP, reverse R, which can be used by host to discover its IP addresses. Both are in a similar fashion. Both you can use it in a know whether neighboring devices, neighboring hardware, which will have a physical. If you want to discern, you have to find out. You can do this command. And also, though you are not family, you are not doing this one. The machines, the devices which automatically do all this. Whenever the device sends the data packets from one device to another device. All these are taking place at the background, though we don't know, with our own open eyes. Right? So you can remember the IP address and the routing table I discussed with the router when we were talking about networking hardware. I said the router is used to connect more than multiple networks. So the router acts as a bridge. So the bridge has already been replaced with the arrival of router. So router maintains a table called routing table held in memory, frequently updated. The reason is once if new network comes in, a new say you have set up a new network, and until you are set up with your router. So then once you start your network setup or else router, once the router is configured, your router, the new setup router, will broadcast the message to the neighboring routers. Hey, I'm a new one. This is my IP address. This is my network ID. Something like it will broadcast. So the neighboring routers, nearby routers, would listen to the broadcast message and update their own tables. So all the routers will talk to each other. So that is the way. Then as a part of layer 3 packet, IP header contains source and destination address, you know that. Then router reads destination IP address, checks against the routing table. So this is how when any data packets comes to a particular router, the router will look at the routing table, which destination the packet should be forwarded. If the destination address not on the same sequence as received port, router send the packet to correct port for routing the destination. So that is what this is all happening at the background. You must know that this is what happening. Although you cannot see with your own eyes, it is at the background. Then, if you look at the internet network layer especially, these are some of the protocols operating in a network layer. Basically, the routing protocols is used for creating the routing table. Say the protocol example RIP, RIP, OSPF, BGP. These are some of the protocols which is used by the routers to create the routing tables. Say, if you, as I said, if you are really interested how router is configured, you have to go to any practical CCNA class. There you can you learn how to set up the router with the help of all these protocols. Say, sometimes if time permits, to come back to university, then there is a lab. Even the technology faculty have a network Cisco lab. If possible, I would take you there and you can see something over there. Since our faculty has not the network laboratory, though I wanted from early days, they have not given to us. But anyway, since it is a new faculty, the faculty of technology, they have got the Cisco lab by investing a lot of money. But no worries, we can utilize that laboratory also in future. When you come to the university, they will. I will ask you the Prof. Sabras Nawaz department to work some experiment with the technology, but only you can work it out. Say, so another protocols like ICMP protocol, all these protocols are there. So what you can do is, if you are really curious about all these, you just Google it and see what is all about BRIP, what is all about OSPF, what is PGP like. So few protocols are there together. Then there are some virtual routers also online you can try out, even if you have a packet tracer from Cisco. Then you can download the packet tracer and you can configure simulated routers yourself and do the work. Anyway, I will also show you later on how you can work packet tracer. So before we work on with the packet tracer, we have to be familiar with all these concepts. That's what I'm introducing the concept one by one in a logical flow manner, chapter by chapter, so you will understand. So the next thing that you can see here, sample routing table. As you know already, there are three networks, A, B, and C. Then there is one router in the middle. You know the function of the router is basically to connect multiple networks together. So how many ports will there be in the router here? Any answers?
So can you repeat it?
There are three ports. The router which sits in the middle of this diagram has three ports because there are three network A, B, and C. So if all those three networks to be connected to the router, there should be minimum of three ports. There may be 4 or 5 ports, but here router mostly 1 port, 2 port, 3 port, 4 port like routers normally we have. But here the diagram you have 3 interfaces. Ethernet 1, Ethernet 2, Ethernet 3, E4 Ethernet, Ethernet 2, Ethernet 3. Right. So routing cable has been prepared by the router. The network ID names are given. The prepared interfaces are there, but actually you will have the IP address. Even for Ethernet 1, what should be the IP address? Ethernet 2, what should be the IP address? Ethernet 3, what should be the IP address? So host AH3. Where is the host AH3? Where is the host AH3? So this is AH3. Network A, host H3. Sends the packet to host CH2. Where is the CH2? This one. So the packet should travel from here to here, then it will go here. Then this whatever the gateway or network will check whether these packets are for these people, for these people, for these people. If not, packet will be forwarded to here. The router will check the routing cable. When the data packets comes, when the data packet comes, this will check the destination address, source address, and other details, and the router will decide, okay, this packet should go to here, this packet should go to here, and the router knows the information. All right, okay, I have information about the packet, the network C, so this should go to this place. So the router will forward this one to C. So the C will check whether the C this one for this one or this one. So this is for H2, so this will be taken. The packets will be received by this device. So this is how things are working on the line. There are many routers around us, so we don't know there are many routers. So all the routers come together to make even that is the internet we call one. So this is the basic structure of IP address. 4. Once again to remind, you look at the IP version 4, 32 bits you have. Basically, you can divide the octets into network and host. Then some based on the class, some portions are for network, some portions for host. So IP addresses are normally mentioned in the dotted decimal numbers. It's easy for human to read rather than binary notation. So you can see here the final table where you can see the binary notation of the IP address. More about this. I have an exercise for you to have a binary conversion exercise after this we can do it. So the next very important section I would like to talk to you with regarding network size analysis. What we do with this activity is, say, for example, once if you happen to be a network manager or administrator or engineer somewhere in any organization, happen to work. So that is the ultimate purpose. No, anyway. So that is the ultimate learning outcome of this course. So once you have completed this course, you should be able to plan, design, manage any kind of network. So I am sure that the knowledge that I am giving you, the experience I am sharing with you, all will help you to set up your own network in yourself later part of your life. When you go to the workplace or whenever you have to be in, or even at your home even. So when you plan the network, you have to do a network analysis. The reason is because if you analyze your network size only, you could decide the resources required for you, especially the IP address, because you know IP address is costly. If you want IP address, you want to buy from the network service provider. So you have to plan that how many IP address you should buy by paying money. You know, it should be given monthly subscription. You have to pay for a long time. Yearly, you have to pay. You have to continue paying the money for the usage of IP address. So you have to plan how many IP address do we need, how many public IP addresses you need, how many private IP addresses you need. Something like you have to analyze. You know how many servers are going to locate, how many PCs that you are going to have in your organization. Or if it is a campus, you can think about there will be a lot of laboratories, even IT laboratories, more than 100, 200 computers. So you may have to plan for everything. How we can assign IP address for all these 200,000 computers? Are we going to assign private IPs? Or are we going to address public IPs? Those two IPs I will discuss it later. Right? Don't worry about what it is all about. I will tell you. So that is we call network size analysis. The questions that you can ask is how big is the network with respect to the number of end systems, router interfaces, switch management interfaces, firewall interfaces, and software. Why we say interfaces here? Switch management interfaces, firewall interfaces. You know that each interface will be assigned with an IP address. Am I right or wrong? So each interface will be assigned with the IP address because each port will talk to. This is where the information goes. So this These are supposed to configure with the IP address. That is what they say. If, for example, you may think this is one device. Do you think that one IP address is enough for this router?
No, sir.
It depends. If the router has more interfaces, if your router has another interface, you may have to have another IP address here. If you have another interface, you may have another another IP address. So you have to plan it. That is what it says. How big is the network with respect to the number of end system? This is end system. These are end system. With respect to number of router interfaces, switch management, if you have any switches here, then firewall, something like. Then how many locations does the network consider? Another important question. For example, your office, your head office will be located in Colombo, Sri Lanka. Then your branches may be in Kandy, Anuradhapura, wherever some other parts of the island. So how many locations does the network consider? You have to think about it. So what are the IP addressing requirements for the individual location? Say if you have a multiple location around the country, how many IP addresses you may need? Then what class of address and how many networks can be obtained from the public number of nodes? By that you have to plan yourself. So all these analysis we call network size analysis. So why we do network analysis? It is the basic requirement when we plan for a network infrastructure development in any organization. One example is given, one network topology is given here. You can see here an example from United States. You can see main office is located in San Francisco in the United States. Then they have regional or international offices in Denver and Houston. And also some remote offices, 1, 2, 3. So you see a very big network, which is extended in many geographical locations. So still these organizations are able to interchange data between them and among them. So the network may be big or small or complex in size, but the basic ideas are the same. Say for example, the main office and the regional office. Maybe they would have connected with the help of the fiber optic cable in their own, or else they might use public internet path to reach these offices. Sometimes they can say for remote offices, say the one remote office in Maldives, that is too far. Then they might use even the satellite communication to connect these places. So it depends about the requirement, the budget that you have when you plan for it. So what do we actually do with network size analysis is you say the table you can see workstation, number of workstation in a campus or in the network in the company or somewhere. If the number of workstation is 1,000, you may plan to have 50 servers. Sometimes now we have IP phones, that means internet enabled phones. I don't know whether you know about it. We call it IP telephone. You can remember those days we had a telephone and the intercom. If you want to talk to internal people, you can use the intercom. We don't use these days intercom. We use the IP telephone because with the network wiring, we also do with the wiring. We do the network wiring helps even to transfer the voice calls with the same infrastructure. So you plan to have 1,000 phones, and you are planning to have 45 router interfaces. Uh, you plan to have 37 switch interface. So the firewall interface, you may have some hardware firewall installed, you may have firewall interface. Then altogether you have in altogether the number of posts that you have in particular place that you are planning to set up a network is 2,144. One example, right? This is not actual size, an example size. Then if you look at the detailed list of network size analysis, all what we saw there, so it's a very big table that you can see. Say for example, workstation, how many PCs are there in San Francisco? Basically 600. How many servers you are planning to have in Denver? It is 7 servers. So like that you can plan yourself these things. You remember that the final assignment for this course will be network development planning project. I will give you all have to do that. Suppose one organization may be given to you. You have to come out with the network infrastructure plan to set up a new network. That is going to be an assignment. So for that assignment to carry out this analysis, the first important analysis to plan you up. Right. So now I come to another important topic is private and public IP address. Say a question that you have to ask: what kind of IP addresses are required? Whether you need private IP addresses or public IP addresses or both. How many of the end system need access to the public network? How many of the end system will be visible to the public? Something like you need to plan. So I am just skipping to the normal mode. So that I will explain what is public and private. I don't know whether I have explained already. Have I explained this one before? Have I? No. Okay. So, but we discussed dynamic and static already. So let me show you the difference between the public and private IP. Here we go to the so look at carefully what we are going to private IP. Such public IP. Say, suppose this is here is your system. There a network setup like this. Sometimes have you know what? great topic. This is your organization, the internal organization. Suppose one example of an organization. Maybe say one campus. Your campus. So you may have an internal network infrastructure like this. Then I would say so the boundary. This will be the boundary. This would be the boundary. So all what is here is your boundary. This boundary we call it private. It's private. So if you go to outside your organization, when something goes outside your organization, you are going out. That means you are going to public. That means meaning you are going to public. Right. Say here, suppose another organization. Here also you may have a different network setup. Just bear with me. You also may note it down yourself, right? Or something like. Anyway, this one also again the private. In the just different scenario I am saying. But when you say internet, this is basically internet is basically we call it internet or WAN, WAN, wide area. So this one basically LAN, local area. In the private post local area, all these are. So far so good, so bad. Are you all right now? Now, so far, have you understood?
Yes, sir.
Right. So, you understood the private and public. Right. So now the difference is, for example, if this PC, say I want www.google.com. Okay. So this PC want to go to Google. Where will be the Google? Google will be somewhere here. Where will be the Google? Google will be somewhere here in the public domain. That is on the internet, right? You agree with me?
Yes, sir.
Google, yes, the Google server definitely should be on the internet. Anywhere in the world. Most probably the server is the United States. So, you should have if say suppose Google will be here. For example, I am just going in a server here. This server we call Google server. Okay. So you see the request. This PC will request for this page. The request will go to here. The request will go. I'm drawing an arrow marker. This will go. Request will go to here. And the reply also will come in the they also will come. Right. this PC you need an IP address. Yes or no? To communicate with Google server, to communicate with the Google server, does this PC need an IP address? Yes or no? Yes or no?
Yes, sir.
Yes. So this PC
Yes, sir.
should have an IP address. Say I am saying this IP address 192.168. We prefer this number. That's what I'm using most of the time. 168.168. 2.20. So this is then only this. Then if the IP address is assigned to this only, you can talk to the person here. Right. Another question. So this is we call a private IP. So we assign this IP to this PC here. So when you go out, when you go to here, when most probably the request will go here through the router. Through the router only the request will go. Then when the request goes through the router, when the router will talk to the internet, this address will be called network address translation. The router will do a function called network address translation because this is, we know this is a private IP address. You cannot communicate using a private IP with the device which is on the public. It is on the public. So if you want to go to the public, you need to have a public IP. You get my point? Right. I will show you the very good example now. Let me show you, say, what where is my command from? Say this is my command from. Let us check what is my IP. IP 1P. So let us see what is my IP address. 192.168.1.100. Make a note of it. Make a note of it. Got it? Are you all there?
Yes,
Yes,
sir.
sir. Got it.
Right. So that's my make a note of it. 192.168.1.100. That is my IP. You know, anyway, this is my PC. You get my information. I'm just showing it. Please never ever do any sort of hacking or something like that. I'm just giving you for a teaching purpose. Don't do any harm things to me. So this is my IP version 4, 192.168.1.100. But do you think, because I am now, am I online or not online? Am I now from my private network, that is the IP address for 192.168.1.100. Since I am communicating with you, so it means that I am coming to the public. Do you agree? Agree or not? So I am coming to the public. So now, very simple thing. Now, if you go to any browser, type here, what is my IP? What is my? Don't sound. Don't make any sound. Be silent. What is my IP? To type what is my IP, click here. Type here. So you won't get what is my IP. This is my public IP. You see, 43.250.241.47. Note it down. You see the difference, my private IP and the public IP. So I am using private IP and the public IP. Since I am coming to you all through internet, so anyway, I am coming via this IP address, 43.250. I have not done this IP address myself. So automatically my internet service provider will assign the IP address with the dynamic hosting control protocol. 43 dot. See the difference. I think you have already noted my private IP and the public IP. So both are different. So whatever the IP that you use in file, you also can test your IP with your mobile phone, whatever the IP. So what we so with the this is private IP. Whatever the within the network, within the local area environment, whatever the IP address you have assigned is the private IP. If you want to go to internet, you may need public IP. You may need public IP. Then the public IP is costly. Public IP is the one you need to buy. This IP, this is costly. Say if you are running a server at your university or wherever at your home, you need to buy a public IP address from the ISP because the server should be available 24 hours, 7 days in a week or whatever it is, and also server should be visible to the outside world, that is internet even. So you should have a public. But however, you don't need, say for example, in the earlier network size analysis, we said there are 1,000 workstations. If you buy 1,000 public IP addresses, how much it will cost? Yes or no? So you don't want to buy that much of public IP addresses because 1,000 computers will be within a network, within a local area environment. So you can assign the private IP addresses for those PCs or workstation or whatever it is. Then any request goes to the outside world, any request goes to the internet, any request goes to the WAN, the router, your friend, the router will help you with the help of network address translation. This will create another public IP to forward the packets or request to the outside world. So this is that is what we call public private. Is it clear or not clear yet? Clear?
Yes, sir.
Clear. And also I would say it doesn't mean that you can't have any public IP addresses here. Say suppose with this switch you may have another server here. Suppose you feel that you have a server here. Yes or no? You may have a server. For example, you may have an email server here. So then this email definitely should communicate to the internet. If that is so, you can have a private address for this server. You can have the public IP also. You can have a public IP also for this server. You got my point. It is not always that you want to use private address within the network. Okay, if you really need any public IP address, like for example, if you would like to run a server within a local area environment, you may have to have a public IP. For example, email server. It is an email server. When you say email server, it should be available publicly because email should come from outside the world and inside. So you should have a communication between the WAN and the LAN. You can have a public IP and private IP. You can configure the public IP for one interface, another interface for private IP. You know that servers, basically the server is like a long box. The server will have a network port more than one, most probably two. I think maximum they may have four network port. Normal PC, laptop will have only one network port, but in terms of server, it can have more interfaces. Network interface. So one of network interface 1, 2, 3, 4. There are 4 ports, network ports. You can configure the 4 IP addresses for this. So one can for private, one for public. You can assign. That can be done. Very simple thing. These are simple things when you do that. Don't think much. The only difference is within a local area environment, you can use private IP addresses. You may need a public IP address only when you go to outside the network. Then you may need the public IP address. As you know, you cannot subscribe to public IP addresses for a whole organization since it is a positive one. You can use private IP. It is free. The private IP ranges are freely available. You can use it without any difficulties. That is what the router has the facility called network address translation, netting. We call it netting. So with the netting, you will be able to go to internet using a public IP. So that is the public-private difference. Right. Okay. So that is the public. Then so the private address, I have explained about the private address. Then you can see the private what it is all about. Then with the network address translation can be used to connect this private address to the internet. So read this please once. I have already uploaded the slide. So these are the private IP ranges. These are the private IP ranges. If it is class A, you can use this IP range. If it is class B, you can. So what is my IP address? Is 43.250. So then my one must be here. I think class A. Class A, and you can remember that class A is mainly used many big organizations like network service providers or ISPs. So I am coming to Coputer. So the Coputer, my router is Coputer Internet subscribe. So most probably the Coputer will have a public IP range with this. Even if you really interested, you can check this info IP address with the KV link. KV means Asia Pacific information center. So where you can get information who is belonging to that IP. So if it is a class C, you can use this range. So the router will never forward packets coming from these addresses. So they will forward with the help of netting from the. So network address translation is explained there. Okay, public versus private. But the diagram that I have shown you here, they have given here. VPN, I will explain what VPN in the next class.